Good morning to all.
Good morning, sir.
Good morning. Is my screen visible to you?
Yes, sir.
Okay. So in the last class we have discussed about, am I audible properly?
Yes, sir.
Okay. In the last class we have discussed about array of pointer and pointer to an array. Okay, and pointer passing array as an argument. Today we'll discuss a very important topic which we can use in our entire data structure syllabus, which is called dynamic memory allocation. Okay, so today we discussed dynamic memory allocation. Okay, now suppose we discuss int a 20. What is the meaning of this int a20? To declare an array A which can store maximum 20 integer type data. Okay. So when we compile this program, then it's allocate 20 to store one integer data. How many byte is required? Suppose 4 byte. So total 80 bytes allocate when we compile any program. Okay, so this is called static memory allocation. This is called static memory allocation. This is called static memory allocation. So now please tell me, what are the disadvantage of static memory allocation? What is the disadvantage?
We cannot add more elements.
Okay, one disadvantage is we cannot add more elements. Okay, so we cannot increase or decrease the size, okay, of the array. So you can say, why not, sir? Instead of 20 we can write 40. But when we execute my program at runtime, we cannot increase or decrease the size of the array. Okay, we cannot increase or decrease the size of the array at runtime. Okay, at runtime when you execute my program, then suppose sometime we required 30 in value, we enter 20, so another 10 required. Okay, so we cannot increase. Again we need to stop my program, again we have to go to the code, change the array size, then again we can we run, then we can insert the value. So if we increase or we cannot increase the thickness of the size of the array at runtime. What is the next point? What is the next disadvantage? What is the next disadvantage? Suppose how many bytes allocate? 80 bytes. Suppose user enter 10 integer data. So for rest 10, 10 into 4, total 40 bytes wastage. Yes or no? Because when you compile my program, it's allocate for 80 bytes. But when we execute my program, then we user enter 10 integer type data. If you user enter 10 integer type data, so it is used total 40 bytes, but allocated space is 80 bytes, used 40 bytes. This space is used by the user. So this space is wastage. Okay, 50% space wastage. Suppose we enter 15 integer data, then remaining 4, so a 5, so 5 into 4, 20 bytes wastage. Okay, 20 bytes wastage. Is it clear to everyone?
Yes, sir.
Okay, so 20 bytes wastage. So this is the wastage of memory. If we declare static memory, static array, then it is wastage of memory. Okay, and another disadvantage is we cannot increase the size of the array. Is it clear to everyone? Hello.
Yes, sir.
Okay, so that's why we came with a new topic which is called dynamic memory allocation. Means at runtime, okay, at runtime we allocate the memory. When we execute my program, at the time of execution, we allocate, suppose user enter 10, so 10 into 4, 40 bytes allocate. User enter 20, 20 into 4, 80 bytes allocate. User enter 100, 100 into 4, so 400 bytes allocate. Okay. So according to the user requirement, according to the user need, user enter the number of element, okay, total number of element into size of that particular element, one element. If you want to store integer type data, we require 4 byte. If you want to store character type data, we require 1 byte. If we store floating type data, we require 4 byte. Double type data, 8 byte. Okay. So according to the user requirement, we can store the memory. We can occupy the memory. So we can reduce this disadvantage. We can solve this problem, that wastage of memory, because memory, primary memory, RAM is very crucial. Okay. Okay, so we can reduce the wastage of memory. Okay, suppose you are doing any long project, a very large number of data you need to process at a time. Okay, if you occupy all the memory, then it is very difficult. Okay, so that's why in dynamic memory allocation, we assign the memory at runtime. We assign the memory at runtime. We reduce or we solve the wastage of memory problem, and also we also increase but decrease the size of the array, increase or decrease the size of the array at runtime when we execute my program. Okay, so this is nothing but a dynamic memory allocation. Okay, so now suppose I'm going to write one program. Now, here we are going to use some function. One is called malloc, calloc, realloc, and free. Okay, these four functions we can use to in dynamic memory allocation. To allocate memory dynamically, either we use malloc function or calloc function. If we increase the size of the array, then or decrease the size of the array, we can use realloc function. And to free the memory, after using the memory, you have to free the memory. So, and rest of the program again use that particular memory. Rest of the program, same program, use that same memory, but a particular memory. Then we use free program to free the memory space. We have used these four different functions. So these four different function is under stdlib.h header file. Under stdlib.h header file. Okay. So here we write as include stdlib.h. Now int main, okay, int pointer, okay, int n comma I declared. So first we write printf enter number of elements. Okay, enter number of elements. Okay, now how many number you want to insert? So at runtime, suppose you declare int percentage %t comma ampersand n. N number of element we want to insert. Now what is the malloc function? We want to write the syntax of malloc function. Okay, this is the syntax of malloc function. First we need to write malloc, then n into size of data type. Okay, now suppose we want to declare any integer type data. Okay, we want to declare an integer type array. Okay, suppose we want to allocate space for 1 2 0 1 2 3 4. Suppose array name is suppose ptr. Okay, we want to allocate space for I integer type data. Okay, so here n value is, what is the n value? 5 into, so each has its own address. Suppose 100 104 108 116 120. Okay, oh, sorry, 112 116. Okay, now size of, what is the data type? Suppose int. We want to store integer type array. We want to create dynamically integer type array. The size of int. Okay, data type is int. So what is the size of one integer type value? If you want to store one integer type data, what is the size?
2 or 4.
4 bytes. Suppose 4 bytes. So 5 into 4, so total 20 bytes allocate. Okay, 20 bytes. This 20 bytes allocate for mm, by the malloc function. Okay. 20 bytes allocated by this malloc function, 20 bytes. Okay. Now malloc function by default return void pointer. Malloc function by default return void pointer. So we need to typecast. So here we need to write data type, then pointer name. Okay, data type, then pointer. Okay, what is the data type here? What type of array we want to create here? Integer, and this is pointer. Okay, this is actually, if we create one integer type array dynamically, int star malloc n into size of in. Okay. Now malloc function return the base address of the array. What is the base address of the array?
100.
100. So 100. So that's why we declare here one variable, pointer variable ptr. So malloc function returns the base address of the array. So what is the value of ptr? Ptr is a pointer variable. It holds the address. The base address of the array is 100. It holds 100. So this is the syntax. First we malloc, then number of element we want to store. How many number of element? What is the size of each element? So number of element into size of each element, and we need to typecast. Okay. So integer star. Why we need to typecast? Because malloc function by default return void pointer, but we need to store the address of integer type array. It is an integer type array. So we need to store the address of integer type array. So how to store the address of integer type array? So that's why we need to typecast into an integer. So that's why int star. So this ptr variable holds the address, base address of the array, which is sent by the malloc function. So malloc function send the base address of the array. What is the base address of the array is 100. So 100 stored within this pointer variable. Is it clear to everyone? Suppose you want to declare any character type array. Tell me.
Sir, then what is the difference between malloc and let's say asterisk ptr equal to and a of 0?
Asterisk ptr equals to ampersand a of 0. And
malloc, both are storing the base address.
yes, both are storing the base address. ptr variable only store the base address. Okay, ptr variable only store the base address. But using malloc function, we occupied n into size of data type. Suppose size of integer is 4 byte, so n value is 5. So 5 into 4, total 20 bytes. These 20 bytes allocate by the malloc function. Then only send the base address of the array. But here previously we need to declare one array. Okay, and one pointer variable. Then we assign the value. Is it clear?
So that n can be a variable also, right? Which we can change.
Where n? Yes, n is variable here. N is variable. N is user input. It is an user input. If you enter 5, so 5 into 4, 20 bytes allocate. Suppose here I am going to write another malloc n into, if you want to create any character array, or okay, so n into size of char. Then we need to typecast because malloc function return void pointer, but we want to store the address of the character type array. So here we need to write char pointer equals to, you declare a character pointer, suppose ptr. Okay, you declare character pointer variable ptr. What is the meaning of this? What is the meaning of this? ptr is a pointer variable. ptr is a pointer variable which stores the address of any character type variable. So similarly here we create one array. Suppose n value, tell me any n value. And when you execute my program, then program asks enter the value of n. Tell me any n value. Suppose 10. So 10, and how many bytes is required to store one character?
1 byte.
Do you know what is size of operator? It's return the size of any data type. If size of char, it's return 1. This function return 1. Size of means size of. If you want to find out the size of any data type, suppose character, integer, float, it returns the size of any data type. Okay, means how many bytes is required to store one element of that particular type. If you want to store one character type element, we require 1 byte. The size of character is 1. We want to store 10 character. So how many bytes allocate here? Total
10.
10 bytes allocate. Okay, 10 bytes allocate. 10 bytes allocate. Okay, the total 10 bytes allocate, and this is a, suppose starting address is 200. Next address is 201, 202, up to 209. Okay, up to
Yes, sir.
209. Hello.
Yes, sir.
Okay. Now this ptr variable holds the base address of the array. What is the base address of the array?
200.
Is it clear now?
Yes, sir. Yes, I got it, sir.
So malloc function clear. Okay. So now tell me how many parameters we have passed here? The number of parameters 1, 2, 3, 4. How many parameters we passed here within the malloc function? How many parameters we passed here?
1 parameter.
One parameter, because suppose 10 into size of character is 1, so 10 into 1 10. So within this malloc function we passed only one parameter. We have passed only one parameter. Is this clear? Size of operator, data type, n, yes or no?
Yes.
Yes, sir.
And why we typecast? Is it clear?
Yes, sir.
Okay, because malloc by default return void pointer, but we want to store the address of any character type array or integer type array. So accordingly, we can typecast. And what is this ptr value? The malloc function return the base address of the array, and we need to store within a pointer variable. So that's why we declare this ptr. If you want to store the character type arrays, if you want to store the character array base address, we declare ptr as character pointer. If we want to store the address of any integer type array, then we declare which is integer pointer. Okay, clear concept? Any doubt, any question, please ask, because this is very, very important. Yes or no? Hello?
Yes, sir. No doubt.
Okay. Others are, what is the problem? Do you not understand, or any problem is there?
No, sir. Understood.
No, sir. Nothing, sir. Got it, sir.
Because nobody is responding, so I am feeling that nobody understood actually. So that's why please respond. Okay, 1 or 2 members.
Okay, sir.
Very, very important when you design any linked list algorithm, a linked list program or stack program or tree program, okay, or graph program. This is very, very important. Okay. Now, suppose this is my, okay, suppose this is my memory. We know my memory, RAM, this is my RAM. Okay, this is already filled out by some data. This is already filled out by some data. Now we want user enter suppose 10 or 100. User enter 100. So 100 into 1. So 100 byte is required, but 100 byte is not there. Suppose there are this 70 bytes only remaining into our RAM. Others all other location already filled up. Okay, only 70 bytes is unoccupied space, but we required 100 bytes. Yes or no? If you want to store 100 character type data, we require 100 bytes, but already filled up by only 70 bytes is unused. So how can we allocate 100 bytes? So then malloc function return null. If malloc function return null, that means malloc function not able to occupy the desired space. Okay, malloc function not able to occupy the desired space. If malloc function return null, that means we cannot proceed further. We cannot proceed further because there is only 70 bytes is remaining, but we required 100 bytes. So how can we allocate 100 byte space within my RAM? How it is possible? It is not possible. Then malloc function say, sorry bhai, I'm unsuccessful, I'm returning null. So null means if pointer value is null, then that means malloc function is unable to occupy the memory. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. So now we declare an integer pointer. That means we want to declare an integer type array. Okay, integer type array. So first, how to declare? Tell me how to declare integer type array into using malloc function. Malloc
N
n,
Into size of
asterisk size of int
yes, size of int,
and int asterisk in the
and we need to typecast int pointer equals to pt.
ptr.
PTR.
Okay. Okay. Now you have to check. Now we have to check that if ptr equals to null or not. If ptr equals to null, then what we can write? Yes, we can print any message to the user, printf,
Not enough memory.
yes, or memory not allocated. Okay, we can write any message, and further we can't do anything, so we exit from the program. We intentionally stop my program, because when ptr value is null, if malloc is not able to allocate the desired space, okay, then malloc function return null to this pointer. So ptr value is null. Okay, then this ptr value is null. If ptr now before doing before further processing, we need to check if pointer value is null or not. If pointer value is null, that means malloc not able to allocate the memory. So memory not allocated and exit. We intentionally exit my program. We stop my program. Else means pointer is not equals to null. Okay. Now we want to store the data. Now we want to store the data. Okay. Suppose user enter any value, n value, suppose 5. Okay. So 5 into 4, 20 bytes allocate. So this is 0th index, 1 index, 2 index, 3 index, 4 index. Okay, so this is address, suppose 2000. So what is the next address? 2004, 2008, 12, 16. Okay, and now this is my PTR, and PTR holds the base address of the array. PTR, it has own address, suppose 3000. Okay, 3000 or whatever. It stored the base address of the array. Okay, so this array represented by PTR. PTR points this location. PTR points the base address, means 0th index address of the array. PTR points this location. Okay, now how to enter the value? Okay, we can write PTR plus I. Okay, please pay some attention here. We are going to write PTR plus I. Okay, so what is the meaning of PTR plus I? It is nothing but PTR plus I is represent the index. I represent the index. I into size of data type. Okay, internally it is like this. We are going to write PTR plus I, but internally it is works like this: PTR plus I into size of data type. Suppose initially what is the PTR value? What is the PTR value? If we write
2000.
PTR plus 0, what is the I value? Suppose 0. PTR plus 0. What is the PTR value? 2000 plus 0 into, to store one integer, how many bytes is required? 4 bytes. So 0 into 4, 0. So 2000 plus 0, 2000. Let's provide the address here. Here suppose the user enter any value, 45. Now PTR plus 1. What is PTR plus 1? PTR value is 2000 plus 1 is the index into, to store one integer data, how many bytes is required? 4. So 2000 plus 4, 2004. So you can see the one index address is 2004. Here we enter the next element, 30. So PTR plus I is nothing but represent the address. Yes or no? PTR plus I, it is represent the address. Yes or no? Because if you want to store the data, we need to know the address. We need to know the address, otherwise how to store the data? Using malloc function, we allocate total 20 bytes. But we need to store the data. Suppose in 0th index, we want to store 45, 1 index 30, 2 index, suppose 90. We need to store. So how to store? We know the location address. Okay. How to know the address? Using this PTR plus I. So this is the syntax. Okay. So else we can write for I equals to 0, I less than n, I plus plus. Okay. Then we can write scanf %d comma PTR plus I. Okay. Okay. So you can write PTR plus I. Is there ampersand is required? Ampersand is required, yes or no? If we write ampersand PTR plus 0, if we write ampersand PTR plus 0, what is the value? Ampersand?
45.
Sorry?
45.
No. Please check. PTR ampersand PTR plus 0. What is
3000.
PTR plus 0?
Address of, okay, sorry.
What is PTR plus 0? 2000. Address of 2000. What is store address?
3000. 30,000.
3000. It is 3000. But this is not the actual address. Actual address is zeroth index address is 2000. So that's why this ampersand is not required. PTR plus I itself represent the address. Okay, PTR plus I represent the address. PTR plus 0 means zeroth index address. PTR plus 1, that means one index address. PTR plus 2 means two index address. And how to calculate address? We know. This is the way to calculate the address. Means internally, it's calculate the address in this way. Okay. So here we write PTR plus I. So in this way, we can store the data. Now print the data. How to print? For I equals to 0. Tell me using pointer how to print the data. If we write print
%PTR plus
percentage D, comma PTR, sorry, we can write pointer PTR plus I. Can we write this? Okay, let's check.
yes.
Okay. Okay. PTR plus 0 is 2000. So if we write pointer PTR plus 0 equals to pointer. What is PTR plus 0? 2000. What is the meaning of pointer 2000? Value at 2000. Value at 2000. What is the value at 2000?
45.
45.
Okay. So if we write pointer, then it is represent the address PTR plus I, represent the address PTR plus 0 means zeroth index address, PTR plus 1 means one index address. If we write pointer 2004, 2004 means PTR plus 1. Okay. What is the value? Value at 2004? 30. Okay. Value at 2004? 30. So here we need to write PTR plus I. Pointer PTR plus I. So PTR plus I, it represents the address. You know how. And pointer PTR plus I represent the value. Any question? Any doubt? Please check.
No doubt, sir.
Okay. Now we already occupied 20 byte space. Now enter the program. Suppose we have suppose this program, this up to this we return up to this. Then there is other code also. Okay, there is other code also. So we need to free this space. Okay, we need to free this space. How to free? If you not use this data. Okay, how to free? Free PTR. Okay. Free PTR. Free PTR. Okay. So if we write free function and give the pointer name PTR, then this location, this link will delete it. Okay, we have not content, PTR not content 200. If we write free PTR, then this link will delete and 20 bytes we can reuse. Okay, again we can use this 20 bytes. So this is the use of free function. So after writing the program, if you want to free the used memory, okay, allocated memory, if you want to free the allocated memory, how to free? Use just write free function name and write the pointer. That means it's delink, it's cut this link, pointer and the base address of the array. It's cut this link. So now if it is cut this link, so there is no value. So we can use entire this 20 bytes. Okay. Any question?
Sir,
Yes. Yes, please ask.
sir, can you explain the functioning of the program, sir? Sir, the scanf and the printout that you have written, sir. Sir, I'm not understanding the value what we will get, sir.
Okay, which one you not understand? PTR plus I.
No, sir, the address one that you have scanner used for the scanner, sir.
What I have right here?
Yes, sir, this
Scanf, PTR plus I. Okay.
yes, sir. We will user will input the
User will input the value of n, total number of element. User enter
sir, but
total
yes, sir.
number of element. Okay. Now, if you user enter 10, so 10 into, if you want to declare one integer type array, here
No, sir, I'm not asking
Which
this one,
one?
sir.
this one,
Yes, sir,
this
this one,
one.
sir.
So here, which
Yes.
part you going to
Yes,
understand?
sir.
Which part? PTR plus y?
Yes, sir. PTR
Okay.
plus I, sir. The user will what a user will
Okay.
input. The,
PTR plus I. I, what is the I value? I equals to 0, I less than n, I plus plus. What is
Index,
the meaning
yes,
of this? Tell me.
so means I is the means we can say that
Index,
I is running from
nothing
0
but
to n.
index.
Yes,
I,
sir.
I indicate
And
the index, array index. Okay. Starting from 0. What is the last index?
sir, n
Hello?
means less than n
N.
minus.
N minus 1. So here,
Yes, sir.
this array 0. Suppose n value is 5. User enter n value 5. So starts from 0. What is the last index? 4. Up to this clear? Yes or no?
Yes, sir. Clear, sir. Yes, sir.
Okay. So using malloc function, when you use this malloc function, then suppose 5 into size of integer 4, so 20 bytes allocate. This 20 bytes allocate. Okay. Now we enter the value at 0th index, 1 index, 2 index, 3 index, 4 index. How to insert the value? We know the address, otherwise how to insert the value? Okay. Do you know what is PTR function? Malloc function here
Yes.
returns the base address of the array, and which is you can store within this PTR. Okay. So what is the base address of the array? Tell me.
2000.
2000. 2000 is
Yes,
stored
sir.
within this PTR. Okay. Now, if you want to store the value within the 0th index, you need to provide the address. Yes or no?
Yes, sir.
Okay. So how to provide the address? PTR plus I. Internally, it is actually like this: PTR plus I into size of data type. Suppose if we write PTR plus 0, what is PTR value?
2000.
What is the value of PTR? 2000
Yes, sir.
plus 0 into, to store one integer data, how many bytes is required?
4 byte.
4 bytes. So 0 into 4, 0. So 0
sir.
plus 2000, 2000. So it's provide this 0th index address. PTR plus I means I, if I equals to 0, that means 0th index address. What is the 0th index address? 2000. Here we enter, then enter the data 45. Now again I increment. Okay. Near again I increment. Next value of I. What is the next value of I?
Yes, sir.
What is the next value of I?
So next value of I is 1.
1.
Yes,
Now
sir.
we want to store the data at 1 index. In 1 index. How to store the data at 1 index? Okay. PTR plus 1. What is the PTR value?
2000.
2000 plus 1 into size of data type. If you want to store one integer
Yes,
data,
sir.
4 bytes
Sir,
is
this all,
required.
sir, I got
One-
it, sir. Sir, this all,
Okay.
sir, means this all got it. But, sir, can you go to the next, means next slide, sir? scan up. So here we have to scan up means scan the PTR plus I address. So means user will input the function. User will input the values, no?
Values, yes.
Yes, sir. So suppose I input
So,
the value 200.
okay.
So the address will be start from means the starting address will be 200.
User enter the value here.
Sir, if the value of n is means suppose that value of n is 5. Yes, sir.
What is the meaning?
Sir, if the user address of a
What
address,
is what value we passed here?
so 200.
Address of A. What is the address of A?
Sir, 200.
Now user enter a value, suppose 15. Where we store? In this address. Here we store 15.
Yes, sir.
So when we write the scanf, here we pass the address. Yes or no?
Okay. Yes, sir.
Similarly, same thing, very easy. Okay. Same thing, here we pass the address. 0th index address, 1 index address, 2 index address, and user accordingly user can enter 45. User don't want, user can enter 85. User can enter any other value, no problem.
Okay, sir. Now I got it, sir. Thanks a lot.
Now you got it. Just we need
Yes,
to
sir,
pass
got
the
it.
address. Otherwise, the computer how to know that where we store the data. So that's why we pass the address. Just simple, simple, एकदम simple है. Yes, sir.
Okay,
Same
sir.
thing.
No,
Okay.
sir. I was little bit confused in the scanner for this one because we were
Okay.
told
Now
that.
it is clear.
Yes,
Sure,
sir.
it is clear now.
Yes, sir.
And why it is pointer PTR plus I?
So
Is
for
it clear?
value at the PTR plus I it will be.
Yes, because PTR plus I, PTR plus 0, which is 2000. So if we यहाँ पर pointer लगा दे, if we write pointer here, the pointer 2000 is value at 2000. What is value at 2000? 85,
45 or 85. Yes, sir.
45. Okay. Then value at pointer PTR plus 1, value at 2004. What is the value at 2004?
40.
30 or 40. Okay. Now PTR, if we write pointer PTR plus 2, what is the value? What is PTR plus 2?
So it will
PTR plus, first you tell me PTR plus 2. What is the value of PTR plus 2?
2008.
2008. Now use pointer. Value at 2008?
90.
So that's why here we use actually the index. These are all index. Here we actually index. Through index, we create the address, and also in this index, what is the value? Pointer PTR plus I, means 0th index value. How to know the 0th index value? PTR plus 0, then pointer. How to know the 1 index value? PTR plus 1, then pointer. Okay?
Yes, sir. Got it, sir.
Any student, any other student, any question? Any doubt? Okay. So similarly, we can use another function which is called calloc. Here, same parameter we use, but no multiplication. Okay. Any variable, it is better to write pointer variable. Now tell me how many parameters we have passed here? within calloc function, how many parameters we are
Two.
passing? Two parameter. One is n value, another is size of. In malloc function, here n into okay, n into size of data type. So here is only one parameter because it is n value multiplied with size of data type. But here it is comma n into size of data type. So same program you can write, just change only calloc by malloc. Calloc n comma size of int. In calloc function also return the void pointer. So that's why we need to typecast. Rest of the program same. Just we need to change this line. Calloc n comma size of the data type in point data int star ptr. Okay. So if we don't store any value, just a second, check the program. You can see this program. Pointer variable, number of element n. Now, sorry, this one. First we use malloc. If check ptr equals to null, if it is null, that means malloc not able to allocate the memory. So we exit from the program. Else we enter the value and then print the value. Let's then free the memory, free pointer. Okay. Enter the number of elements, suppose 5. So it returns the address. You can see here we return the address. Which address it is? What is the address? Which address? Tell me, what is this address? 7083024, which is returned by the malloc function. That means base address of the array. Okay, like this. Here base address of the array is, here base address of the array is 100. Okay, what is the base address of the array? 100. Similarly, it's written the base address. So base address is 7083024. Okay. Now that means if we malloc function able to allocate the 20 byte space. Otherwise, malloc function return null. Okay. Now we insert some value. Sorry. Suppose 45. What is this address? Base address. Okay, means zeroth index address. Here you can see we print the zeroth index address, each index address, zeroth index, 1 index, 2 index. Now enter any other value, suppose 30. What is the address of the 1 index? Tell me. What is the address of the next index?
Sir, 028.
028. See, now we want to store the value at 2 index. Okay. What is the address?
032.
32. Okay. Next I want to 0, 1, 2. Now third index. Third index
36.
enter 35. What is the address?
36.
36. Now enter fourth index value. Suppose what is the address? 40. 36 plus 4, 40. So the elements are 45, 30, 90, 35, 76. Okay. So malloc function return the base address. This is the 0th index address. You can see malloc, if we print the value of PTR, it is also 070830024. Okay. Similarly, calloc, just write in different way. N comma size of point. Here we write malloc n into, here n comma. Rest of the program same. Okay. Now, any question, any doubt regarding this? Any doubt? Okay. Now, if we don't want to enter any value, if we don't want to enter any value, after that, which is the class? Next class, lab. Hello.
No, sir, not a lab class. Sir.
Probability.
From 12 o'clock.
Sir, economics, sir.
Huh?
Sir, after
Next
this
class,
class, sir, it is economics.
Economics.
Okay. After this class, okay. Now, suppose we are not enter any value. Using malloc function, we allocate the memory, but we don't want to enter any value. You can see what is the output. Suppose we enter the value 5. You can see it will print the garbage value. So malloc function by default store the garbage value. But if we use calloc, okay, just omit this code. I just command line this code. So inactive. I just inactive this code. Okay. Okay. Now, if we execute, what is the output? 0. So by default, you can see, by default, malloc function store any garbage value, but calloc function store 0. Okay. Calloc function store 0 and malloc function store garbage value. Okay. Is it clear the difference between this malloc and calloc based on initialization? The next class we will discuss structure, pointer to structure. I have already discussed structure.
This difference again.
Sorry?
Sir, what
Hello?
is the difference between calloc and malloc?
I have shown that if you use the malloc function, if you are not assign any value, it store garbage value. But if we use the calloc function, by default it stores 0. Okay, if you don't assign any value to the array, by default it is stored 0. Okay, this is one of the difference, and we'll discuss other difference also. Okay, calloc malloc we'll discuss in the other. Okay, continuous memory allocation and all we'll discuss.
Sir,
Yes.
sir, can you send these .c files to WhatsApp group?
Yes. I will send.
Okay, sir.
4 student is absent. 4 or 5. Tell me who are the students. Tell me, because it is already time. Okay, I will capture this attendance. Okay, and then we put that. Okay, you may leave now.
Thank you, sir.
Okay,
Thank you, sir.
thank you.